Good morning, everyone. Today we're going to continue our discussion. Wait, I haven't recorded. Have I? We're going to continue our discussion on multiple linear regression. So just a quick review of what we have discussed so far. We said that there are many ways to install packages. One of them is to install the packages individually via the script window or the source window, or we can install packages here from the packages window pane. You just click install and then identify the package that you want to install, and then you can install several packages here. Just separate them with the space or comma. Okay, so last time what we did was to load or install Psych, HMISC, Broom, Tidyverse, Pastex, DeskTools, etc. These were the packages that we installed, and we said that some of these are used for descriptive statistics like Psych, HMISC, Broom, Pastex, DeskTools, SchemR. Some of them are used for multiple linear regression, OLSRR. Some of them are used for generating results like Stargazer. Some are used for plotting, GG45, GG-Ally, and also part of Tidyverse is ggplot2. So far, you have made use of some of the functionalities of these packages, but there are still many functions that we haven't really explored. So of course, it will be impossible to really study everything in this course. But I hope you get you become you are encouraged to on your own explore more, okay, and learn new things that we are not able to discuss in class. Okay, the data that we're going to use is wage, and we said we need to load it first to our environment. As of now, I don't have any wage data set here. So there are different ways to load this. So we can use the readr package. There's this function called read_CSV. The advantage of putting your data inside your project, just like this one, if I check the files here, I have my wage data set inside my our project, FINARTS K31, T2, etc. So it's very easy to access data or data uh, from your project. Unlike if it was saved in another folder, then you will have to identify the file location of the file location. Okay, so here I'm using read_CSV, and then we have here wage.csv, and then we can identify column names is equal to true. There are other additional uh, parameters that we can use here, but for our purposes, we'll just use this wage CSV. Okay, so you can also use this class, this import dataset. If you click this import dataset, and since it's a CSV file, you can use either from text base or from text readr. You can use any of them. Okay, so if I click this, and then here class, it will give us the code. So since we're using readr, it automatically codes for us library readr, and then here we can change the name of the data set, and then read_CSV. Okay, and then you will be asked where that data set is. Once we look for that data set, which is supposed to be inside our project, then it will automatically give the location here. All right, and it includes already the viewing of the data set. We can change this name here. Okay. All right, so I won't do that. Okay, anyway, let me do that. So browse. So it's inside my FinArts art project here. It's wage there. Open. All right, then automatically it names the file as the name of the file. Okay, so the name of the object will be the same as the name of the file, wage. And then you can see here, you can you can modify this already. For example, education, we know that that's numerical, quantitative, so it's okay, double. Experience is double. Tenure is double. Race is character. Gender is character. Civil status is character. Number of dependents is numeric, double. Hourly wage is double. So it correctly guessed the data type. Okay. If it happens to be, for example, if it happens to be, let's say, if it defaults into integer, okay, and you know that it should be there, it's classified as integer, and then you can see here in the code that, okay, you can see here that an additional code here, okay, experience is equal to call underscore integer, okay, so this is an additional code that makes experience integer, okay. So, but it's not an integer, so let's just make it double, okay, which double means it can take on decimal places, all right? So everything is okay, character, character, character. So you can see here, later on we'll talk about factor. Okay, we will change this into a factor. We discussed last time that a character variable, if it can be used as a classifier, can be converted into a factor. There's a difference in a just a character and a factor. If I click this class, race, okay, please insert a comma separated list factors. So I'm going to, for example, identify race, comma, gender, comma, civil status, but I will not be doing that. We'll do that next time. Okay. All right, so let's just leave that as character in the meantime. But we take note that this is race is supposed to be a factor. Okay, I have my reason why I'm not converting it yet into a factor because I want to show you something. Okay, so with that, wage, and then here is I will not skip anything. First row as names. Okay, click, and then delimiter. It's a comma. It's a CSV file. Okay, when I import this class, what happens? When we import this, automatically in the console, you'll have here the code chunk. Okay, here. So it created an object called wage there. First, you can see here, oops, sorry. It loaded the readr package because it's needed to use read underscore CSV. Okay, or you can load library tidyverse. Why is it okay to load tidyverse instead of readr? Because readr is also prepackaged with tidyverse. The tidyverse function, the tidyverse package consists of several packages, including readr. Okay, so uh, here read underscore wage, and the file name is wage.csv. Okay, if this was located in another location other than the R project, then it would have identified here the file location where this data was coming from. So it simplifies, class, putting your data set inside your R project simplifies the coding. So here we have column types is equal to columns. And then since I clicked this a while ago to be integer, and then I reclicked it into double. Okay, so, but actually we don't need this anymore. That one, sorry. Okay. Anyway, it has already run, so no problem. And in fact, it already printed here because a part of the importing data set, it includes view wage. Okay, let's go back here. All right, any questions so far? Could you kindly chat, please, if that review is okay, clear ba yung class? Any questions? Attendance mamaya na lang. May I have class or confirmation if it's clear or not? Yes or no, please? Thank you. Thank you. Okay, that's good. Thank you so much, class. All right. Okay, so we have imported the data set. Okay, so what we did last time was to look at several descriptive statistics or structural, for example, we can just look at the structure of wage, and that will give us information about your data set. Okay, so it's a special table consisting of 526 rows of observation by 8 columns. Okay, so it's a table data frame. It's a data frame. So these are the different classifications, structural classifications of our data. And under this one, you have dollar education means that you can access education via wage. You cannot access the variable education individually. Okay, you have to attach it, or you have to uh, identify where it's coming from, its wage, and then dollar sign education. So this is numeric together with experience tenure, and also the other two variables, number of dependents and hourly wage. You have character for gender, race, and civil status. Okay. Okay, and then the data type. Okay, education is numeric, so it's double. This is the measure of a numeric. It can be either integer or double. For race, it's character. Okay, for number of dependents and hourly wage, it's still double. All right, so that's what happens when we use structure. For the others class, the scheme function, the desk function, the describe by function, we looked at that last time, so I will not run that now. Okay. Also, we discussed last time, uh, R has very powerful functions on plotting. One of them is to plot, is a plot function. And then we are asking R to plot education on the x-axis. That's the default, whatever comes first is the x, and then hourly wage is the y, and the main is the title of the plot. And do you recall, class? Will this work or not? Kindly chat, please, your answer, or unmute yourself, or raise your hand. Anyone who wants to answer this, will this work, class? As a review, yes. Okay, thank you. No. Raul, why? Why no?
Sir, kasi wala pa sila sa environment, di pa na-identify.
Okay, it's not in the environment. And how do you make this work? Yes.
Either you identify the code or there's a function that I forgot already.
Okay, so you can just
Attachment. Yeah.
okay, attach. The function is attach. You can type attach here and then wage. Okay, or instead of attaching, what you can do is just directly type here wage and then dollar. Okay, this is what we were discussing last time. The use of the dollar sign will allow us to access whatever are the elements or contents of the particular data that's already recognized by our environment. Okay, this is wage. Wage, just like if I type wage and then type dollar, okay, it allows us. There's this intelligence here. It knows what are the elements of wage, and it gives us the option. Okay, what do you want to get under wage? Because the symbol dollar will identifies that we want that specific element or variable inside that object. All right, so this will not work because education and hourly wage are not recognized. It's not part of your environment. So we said that what we can do is to if you use attach, if we run this as part of the code, then we don't need to identify the object where education is coming from. It will run. Okay. So this will run. We know that. Okay. And also last time we said that part of the assumptions of classical linear regression model is that there should be linearity. The relationship between your dependent variable and independent variable they should be linear, or at least they should be correlated. Okay, and we looked at several plots. For example, these pairs that panels gives us a very good plot of the correlation among the variables, and also GG pairs. But we don't want that the independent variables are highly correlated. Okay. Now again, last time we plotted this, and since wage contains character variables, it will form part of the correlation plot. And we said uh, doing a correlation plot with the independent variables, or independent variables that are character, is of no practical use, because character variables do not actually have quote unquote correlation with the other variables. So what we did here was to create this object wage1, okay, and then wage is our data, and then we get a subset. This is rows and columns, okay, rows and columns, because this is a data frame. Wage is a data frame, and data frames always consist of number of rows and columns. It's a rectangular type of data containing rows of observation and columns for your variables. So what we did was to remove columns 4 to 6, which include your race, gender, and then your civil status. Okay, so if I run this, there, wage 1. You can now see that wage 1 is different from wage. Wage 1 contain only your numerical variables: education, experience, tenure, number of dependents, and hourly wage. So when we have created a subset that only contain your numerical variables, then it will be better. It will now be better to do the pairs that panels on that, or the GG pairs on that. All right, so let me just run this. So this is coming from GG ally. So the GG pairs function will look like this here, there. All right. So what's good about this is that we have on the diagonals, we have the uh, distribution of the variable itself. Okay. And then on the bottom part of your array of your plots, you have the scatter plot. Okay. And on the upper part is your correlation. Okay. So these correlations, okay, you're pairing this with correlation of experience and education. So these are all correlations with education, correlations with experience, correlation with tenure, correlation with number of dependents, and correlation, okay, that's all number of dependents. And we're really more interested in getting the correlation with your hourly wage, okay, which is this one, okay. You can read this from here or via here, horizontal or vertical. This is called the correlation of hourly wage and education, 0.4, and it's statistically significant. With experience, this is significant at 0.1%. I hope you recall that. This is significant. The two correlations, the two stars here tells us that this is significant at 1%. And is there a 1 star here? No 1 star. 1 stars signifies that it is significant at 5%. No star here means the correlations are not significant. And that can be seen also by the very low correlation coefficient. All right. So we would like that hourly wage be highly correlated with the independent variables. Of the independent variables, of the predictor variables, you have your education that has the highest correlation with hourly wage, and then tenure comes next. Okay, so if we were to use all of these variables as predictors, then most probably education and tenure may enter the picture, and then number of dependents might not be a significant predictor of of hourly wage, because the correlation between hourly wage and number of dependents is not, the correlation is not significant. So there are no stars here. Okay, pause for a while, class. Any questions so far? This is just a quick review of what we have discussed. Could you kindly chat, please, if I'm being clear with my review? Okay, good. Thank you. How about the others? Okay. Thank you. Okay, no questions so far? Okay, no questions. All right. So let me just close this. So last time we also started using the LM function. The LM function means linear model, and it's used to run a regression. Okay. What we did last time was we created an object called mod1. You can name it any way you want. And this is an assignment operator. And then we're using the function LM. And this one is your dependent variable, hourly wage, associated or regressed on education. Now, why did we use education? Because we saw from the correlation that education has the highest correlation, okay, between hourly wage, our dependent variable, okay, among the other variables that as far as the correlation is concerned. Okay, I closed it. In fact, if we recall, number of dependent number of dependent is the least correlated. Okay. Okay, where am I? I'm here. All right. So if I run this, okay, so here now I only have wage and wage one here. If I run this class, it will create this object mod1, which is a list. Okay, list. If I click this, you'll notice that these are the lists. Okay, 1, 2, 3, 4, 5, 6, 7, 8. It's a list of 8. Okay, as stated here in our, okay, 12, wait, 12, 1, 2, 3. Prints here. Okay, list of 12. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So sorry for my counting. These are all the elements of mod 1. So this just means that there is a sub uh, listing here, there. Okay, but all in all, there are 12. Okay, all in all, there are 12. So that's what this means in the environment. And take note, it's part of the data. So data frame and lists will be part of your data. Okay, so we can access quickly. What we did last time was use the names function. If I use the names of the object mod1, it will generate a list. Okay, so these are the list. This is the 10th, 11th, 12th. So these are the 12th element of your object mod1. Okay, so coefficients, residuals, etc. Which means that we can access these residuals contain all the residuals of our model. So there should be 526 residuals because uh, our our data has 526 observations. All right, and I think we ended here. Summary. Okay, let's quickly take a look at this. So what can we get out of the summary function? It will summarize. Okay, it will summarize the regression output. Okay, very quick review. Okay, let me increase the, and then let me run this, Control Enter. Okay. So the first one is it tells us the formula that we use. The formula is hourly wage regression education. and then we identify the data. Data is coming from wage. And then it gives us a descriptive statistics of the residuals. Okay, the minimum is -5, the maximum is 16. Okay, the median is -0.96. All right, then we go to the coefficients because this is developing the, okay, sorry. This is a simple linear regression, so we're using education as our beta 1. Our intercept is your beta null. Okay, so very quickly, what is the meaning of this? What's the meaning of -9.9, -9.1? Anyone, please? Meaning of our beta null, which is our intercept. What's the meaning of intercept, class? This is the, anyone, please? What's the meaning of the intercept? -904 or 05 to round it off. Meaning, class? What's the meaning, please? Okay, sorry. So I saw an answer here. Okay, when y is 0, okay, negative correlation. Okay, that's not the correlation. Okay, -0.9, class, is, okay, which is the intercept. So there's that correct answer there. Let me annotate this. Okay, so this one, class, let me round it off. This is your beta null, class. -0.91. Remember, the model that we're generating here is hourly wage. This is our dependent variable. Hourly wage sub I is equal to -0.91 plus 0.54 times your beta 1. Your beta 1 is education. Okay, and I'm not adding a I'm not adding an error term because I'm using this, the predicted value. Okay, so this one, class, is your intercept, and it refers to, that is the value of your hourly wage if your education is 0. Because if you take a look at this equation, class, if we let education be equal to 0, so this cancels out, then what's left is -0.91. So it tells us hourly wage is equal to -0.91. And that's the value of your dependent variable hourly wage when your independent variable is 0. If I replace this with 0, it will be 0.54 times 0. So that's 0, right? So what remains is -0.91. All right. So the intercept is supposed to be the value of your dependent variable when all your predictors, when all your independent variables are equal to 0. Okay, because you're going to replace your independent variables with 0 times what's your education? 0 times whatever variable you replace it with 0, then this will cancel out. The values here will cancel out. What remains is your -0.91, and that's your intercept. Okay, but of course, we don't put any physical or significant or practical meaning to that because it's impossible to have an hourly wage of -91. So does that mean that if I'm not educated, I have 0 years of education, then I will have to pay the company with 0.91? because that's what this means. Hourly wage is the rate a person gets on an hourly basis. All right, the next, this is your B1. What's your B1? This is your slope. This is your slope, class. So it's 0.54. So what does it mean? What does that mean? Can anyone please give me the meaning of 0.54? Anyone, please? We have to know how to interpret that, class. No? What's the meaning of 0.54? This is your slope, your B1, which is your slope. And it means, anyone? What's the interpretation of 0.54? Okay, I see an answer here. Rise over the run. Yes, that's the again, class, kindly share your answer to everyone. My answer dito si Fredericks. Incremental increase for every unit of the independent variable. Okay? Kindly share your answers, class, to everyone. All right. Rise over the run. But let's be more specific. Okay, thank you for your answers. So the meaning of this is the slope, or this is the rise over run. But as Frederick said, it means that for every one, so education, let's increase education by one. But what's the dimension of education? Education is in years. So we can say here for every 1 year increase in education, there is a corresponding what, class? Sorry for corresponding, I'll write here. Corresponding, there is a corresponding what? Corresponding 0.54 what? 0.54. Now you have to take a look at the dimension of hourly wage, because this is the effect of a 1 year increase in your dependent variable, in this case education, on your dependent variable, which is what, class? Your hourly wage. So we can say corresponding $0.54 increase or decrease, class? Increase or decrease? The answer is yes, increase. Correct. It's increase because it's positive. If this is positive, okay, positive siya, then increase. Increase, okay? 0.54 increase in our dependent variable, which is hourly wage. Okay? And then comma, you have to include this. Sorry, I'm going to write it here. Ceteris paribus. Okay, let me repeat that. For every 1 year. Okay, why am I using year? Because your independent variable education is in years. So you have to follow the dimension of your variable. For every 1 year increase in education, there's a corresponding 0.54, okay, $0.54 increase in hourly wage, comma, in hourly wage, then comma, ceteris paribus. So what does that mean, class? What does that mean? We're only affecting that 1 unit change in education, and not on the other independent variables. Okay? Ceteris paribus means all things being the same. So you're not going to change the other variables, you're only going to affect a 1 unit or 1 year change in your education. All right. Any questions, class? Kindly chat please if the explanation is clear. Kung clear na sa atin yung slope at saka intercept. Okay, thank you. Thank you. Okay, waiting for the others to give their feedback. Please feel free to ask questions if you have any. Okay, good. Thank you. All right, so let me clean this first. All right, then we have here the standard error. Okay, we're going to explain this as we go along. Okay, this one, class, everything here you should know. You should understand what's the standard error, what is the t-value, and what is the probability. Okay, so let's just focus here first on the probability. Okay, and take note that when we do regression, we're actually doing an inference. We're doing inferential statistics. Okay, let me write again. We're doing inferential statistics. Okay, so what are we inferring as regards this one? So the null hypothesis, recall from your stat, is that I'll call this your beta. Your null hypothesis is that your beta is equal to 0. Okay, and then your alternative is that your beta, and then also, so this is the first, and you have another test. Okay, wait. Okay, so the other one is, so HO, null hypothesis number 2, is that your beta 1 is equal to 0, and the alternative hypothesis HA2 is that your beta 1 is not equal to 0. Okay, so we can answer these questions. Okay, what's our conclusion about the intercept, about beta null? Okay, so we say that this one, this is the p-value. It's 0.187, and the p for your beta null, for your intercept, is, the p-value is 0.187, and this is greater than 0.05. The benchmark used normally is 0.005, 0.05. So we compare the p-value to 0.05. And since the p-value of intercept is greater than 0.05, then answer is we reject the null hypothesis that your beta null, we fail to reject, no? We fail to reject. So it's a failure of rejection. We fail to reject that the null hypothesis is equal to 0. Okay, so if it's a failure to reject the null hypothesis that the beta null is equal to 0, it means that it's a value other than 0. Hindi siya 0 class. Okay? So if it's greater than 0.05, then we reject the null hypothesis. On the other hand, for education, okay, for education, the null hypothesis, the p-value is 2e to the negative 16. You know what this means, class? 2e to the negative 16. It means, okay, so you write 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then you write the 2. Ilan na to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 2. There. So this is what this means, class. 2e to the negative 16. So this is very, very much less than 0.05. Okay? And we say that the conclusion here is if the p is low, so let me write this. If the p is lower than 0.05, the null must go. So let me repeat that. If the p is low, the null must go, which means that the null must go means we have to reject the null hypothesis. So for intercept, we say that beta null is equal to 0, p-value is 0.187. So we fail to reject the null hypothesis. Okay, there is failure in rejecting the null hypothesis that the beta null is equal to 0. Okay, so there's strong statistical reason to believe that the beta null is equal to 0. On the other hand, the education with the p-value equal to this small amount, which is less than 0.05, then our conclusion is we reject the null hypothesis that the slope is equal to 0. There's strong statistical reason to believe that the slope is a value other than 0. In fact, its value is 0.54136. Okay. All right, let me pause for a while. So far, class, any questions? Are we clear? Hello, class? What's your feedback? Any questions? Clear ba yung ano natin, yung null hypothesis at saka alternative hypothesis? Is there any chance the p-value? Yes, of course. Yes, thank you for that question, Glenn. Yes, definitely. The question is it possible that the p-value for the intercept is significant, which means less than 0.05? Yes. Okay. Now, that brings me to the question. Since the intercept is not significant, and you cannot see any stars here, okay, should we remove it from the equation, from the model? What's our model? Hourly wage y is equal to beta null plus beta 1 plus your residuals, right? So should we remove beta null from the equation? Okay, the answer, class, is the practice is do not remove the intercept as part of the equation. If, on the other hand, your B1 is not significant, then you should remove that. But for the intercept, we normally do not remove the intercept. We still maintain it as part of the equation. Okay? All right, very good question, Glenn. Thank you. Okay, are there any more questions, class? Any questions, class? Okay, so let's move on. I hope everything is clear so far. Clear natin. Okay. How about this one, class? You have here some details. So residual sum of the squares, let me just So we have here residual standard error 3.378. This is just like the standard error, standard deviation of your residuals. Okay, so remember that we have residuals, right? We have residuals and we have the value of residuals 526 all in all, same as your data, because we have a an actual data, okay, minus your predicted value that will generate your residuals. All right, and here your standard error of your residuals class is 3.378. Okay, the higher, of course, the standard error, means that your model is not that good. Okay, we'll discuss this in greater detail on 524 degrees of freedom. Okay, we'll get back to this again later on. And then we have here multiple r squared. So that's r squared, and our r squared is 0.1648. All right, what does that mean, class? What does that mean? It means, class, that, so we're looking at your hourly wage. This is your dependent variable. We're taking a look at its variability, okay? And it means that 16.48% of the variation of the variability in hourly wage can be explained by your predictor education, okay? So you're using education to predict or to explain hourly wage. This tells us that it can explain 16.48% of the variability of the variance in your hourly wage. Okay? And there's another adjusted R squared. Okay, well, this is adjusted R squared. Okay, sorry. This is your adjusted R squared. Your R squared is simply the one R squared, no. So where's that eraser here? Ayaw na, sorry. Okay, naghang siya, class, no? Naghang. Okay. Naghang yung list. Anyway, class. Anyway, let me just delete everything, then close this. Okay, there's another R squared, adjusted R squared. For now, this doesn't mean much for us, class, kasi adjusted R squared, and it's denoted by this one, that bar there, and ADJ for adjusted, and it's equal to 16.32. Okay, this one. So we can see that your adjusted R squared is lower than your R squared. Okay, always your adjusted R squared will be lower than your adjusted R squared. And this is very important for multiple linear regression. Okay, for now, class, for now, since we're doing simple linear regression, this will not have any meaning at all. But later on, when we do multiple, then that comes in very, very important. Okay. All right. All right. Okay, now you can access the different elements of your mod 1. Okay, let me control alt I. Okay, for example, I get the first 6 observation head, and then mod 1, sorry, mod 1 dollar. So what's contained in your mod 1? Coefficients, residuals, all the 12 elements here. And if I click residuals there, it will give me the first 6 observations. Okay, first 6 observations. So let's take a look at the head, mod 1, dollar sign. Let's get the residuals. Okay, so this is the first first six values. And then let's also get head mod 1 dollar. Okay, let's take the fitted value. Sorry, I have a double here. Okay, so if I run both, all right. So where did I get negative 1.95 here? I guess we discussed this last time, and I said that it comes from the actual value, which is 3.10, okay? 3.10. So that's 3.10. And then if I subtract the predicted value, the fitted value is this one. Okay. Okay, sorry. Let me put it here inside. All right, negative 1.91. I should have, okay. Their class. These are your residuals, negative 1.95. You have here negative 1.95. Okay, so are we clear, class, on the residuals? Kindly chat, please, if we're clear as far as the generating the residuals. The residuals were generated using the mod 1 function. It falls under the residuals object in the list. Okay, thank you. How about the others, please? Okay, all right. So we have discussed the meaning of the intercept. We said that the intercept stands for the value of your dependent variable if all your predictors, if all your independent variables were equal to 0. So that goes for a simple linear regression or for a multiple linear regression. If you substitute 0 to the all your independent variables, even if there are parameters, even if they have their own slopes, the slope times the value of your independent variable will be 0. So that what remains is your intercept. Okay. Now make sure you have loaded Broom, the Broom package class. If you have not, kindly do library Broom, okay, and I'll show you what this gives us. The function of Broom class has the Broom package has this function augment. Okay, so I'm using the augment function. I'm creating this object mod.1 resid. You can name it any way you want. Okay, so mod.1 is the result of running the function augment for our model 1. Okay, so if I run this class, all right. So you can see here that mod.1 resid, okay, it's this one. It's also a data frame. It's under data. Okay, so if I click this, and then what do we have here? Okay, can you run it first and then tell me what you see? What do you find, class? Any comment, class, about what this object mod.1 received, which is coming from the augment function of the broom package. What does that give us, class? When you run that, you should have here the object, 526 observations of 8 variables. But what's inside? What are the contents? Anyone, please? What do you find under that? Using the augment function, and you run augment to the model 1. Hello, class. Any feedback? What can you see? What do you see in this object mod1 that received? Okay, I'll call on somebody to show the result. Okay, Glenn, could you kindly, I'll stop share, and could you kindly share the result of your object mod1 that received? Glenn. Okay, good. Okay, thank you. Okay. All right. So what are the columns there, Glenn?
Hourly wage, education, fitted,
Yeah.
residual.
Yung una muna,
Yeah.
no? So you have your dependent variable, andyan, di ba?
Ayan.
And then you have your education, andyan. And what's the third one?
Fitted.
Ano yung fitted, Glenn?
Yeah. I think this is the actual value.
Ang actual is hourly wage. Di ba? Yung fitted, that's the predicted value. That's the value generated using the model, no? Right? Okay, Glenn, tama?
Yes, sir.
Ano naman yung receipt?
Yung difference.
Yes, that's a difference. So that's a residual. So that's 3.10 minus 5.050 ba yun? 5.05. You get your negative 1.95. That's the residual. Okay, and there are other metrics here, class, which we're going to use later on. Yung that hat na yan, hindi yan yung predicted value na hat, ha? That's really more for the leverage, which we're going to discuss as when we go to diagnostics. Tapos yung Cook's distance, ito naman, class, it's a metric used for determining if that observation is influential. No? Kasi later on we'll learn that there are outliers, there are leverage points, and there are influential points. Tatlo yun, no? Outliers, okay, outliers, we can get it from Tukey's box plot, no? Yung ano niya, remember yung first quartile, second quartile, then the IQR, and then 1.5 times, etc., etc. Any points outside of that, okay, outside of the whisker, class, will form part of your outliers. And then outliers, then there are leverage points. Okay, these are very important kasi, class. And then yung last pala, yung influential data points, which is the Cook's distance. Importante to, class, kasi yung pag mataas yung Cook's distance na yan, it can mean that that's an influential point. And why are influential points important? Because influential points tend to affect the values of your betas, the intercept and the slope. Kung tanggalin natin kunyari yung value na yan, yung observation na yan, yung data na yan na mataas yung that has a high Cook's distance, it can affect your model tremendously. Ibig sabihin, let's suppose an observation there has a high Cook's distance. Then by removing that, class, it can change your parameters. We will explain this in greater detail. Thank you. Thank you, Glenn. Okay. So let me go back. Let me share again my screen. All right. So what we see here, class, is, as Glenn shared with us, this one. Okay. Is there a question? Yes. Thank you, Raul. Yeah, standard residuals. Yeah, correct, correct. Thank you for your answers. No? That's correct. So you have your actual class. This is your actual data point, diba? This is your observed value. This is your what class? This is your predictor. This is your class. This is sorry. This is your independent variable or predictor. This is your predicted value. This is your residual. Okay, as I said, ito class, these are other values related to your residuals, which we will be using later on. Okay, so you notice that it has a high in decimal place na, di ba? Okay. There. Ilang decimal places yan? 9 yata. We can remove that class, the decimal place. Okay. Take a look at this class. So we can use the round function. Okay, could you kindly try this class? Round and then copy this function broom augment mod 1 comma 3. That will give us that will give us class only 3 decimal places. Okay, just rounding it off. Okay, could you kindly try? Okay, and please chat if you have tried and if indeed it rounded it off to 3 decimal places, because we might not need really an output for this that's 9 decimal places. Kindly chat please if you were able to get an output that has only 3 decimal places, making use of the round function. Okay, good. Thank you. All right, so that's another thing that we learned today, making use of the round function. All right, now you can of course create another data set where it only, if suppose you only want the 1, 2, 3, 4, the first 4 variables here, you can of course subset by just getting from the mod1 dot receive only the first 4 columns. So that will be, if you're interested in that, let's just quickly review that. Okay, I'm going to create another one, mod1 dot receive 1. If you want to overwrite the existing one, and then you can just copy this. Okay, or let's just use this. Okay, so we already have mod1 receive. So mod1 dot receive, we already have this mod1 dot receive, and then brackets, and we want all the rows but only C, or just okay. So this will generate class an object mod.1 receive, which overwrites the existing one, which only contains the first four columns. Could you do that, please? Or you can, to preserve the other one, let's just put here mod1, okay, or maybe mod2, no, mod1, maybe receive 1, to preserve the this other one. Okay, if I run this, so I now have this object mod1 receive 1, and there are only 4 variables there, and you can see now that it only contains, let's say these are the only ones that you need in the meantime, so you can create this object. Okay, so I hope that's clear. All right, now let me show you class making use of the ggplot function. Let me show you. Let's plot now. Let's plot ggplot. Then we're going to use this data mod1 dot receive, and we know class that mod1 dot receive contains what's contained in mod1 dot receive. It contains 8 variables, right? Hourly wage, education. Okay, so what we're going to do is let's identify the x-axis. So this is the object that we're going to use, mod1 dot receive, or you can use of course wage, because you have there the education and hourly wage. However, we're going to use other points there in your mod 1.3 seed. So the plot is geom point, so it will give us points class. And then take a look at this. You have this stat underscore smooth. It will generate a linear model line and it will not put the standard error false, and then plus geom segment. It will limit the lines. Okay, and then here I'm putting aesthetics. X end is equal to education. So your X will end on the value of education, and your Y will end on the value of the fitted value, that fitted. So R will understand this because we have identified where it's coming from mod 1.receive. It's already identified here. It's like attach, right? So it knows where that fitted is. Then you can identify the color and the size. So let me just share with you to save on time. Control C, let me chat that. Okay, so could you kindly copy that and let's run this plot, ggplot, and see what happens. Right, so could not find ggplot because I haven't installed. So let me put here library. I can use tidyverse, what I mentioned to you class a while ago. Let's use tidyverse. It means I haven't run this library tidyverse. Okay, this is what I was telling about class. The package tidyverse has incorporated with it the other packages. It's like dplyr, forecast, ggplot2. So it contains ggplot2, also lubridate, etc. So these are among the many packages that it contains. All right, it contains ggplot2. Okay, but of course you can also use library ggplot2. Okay, so this will run now. A while ago it said that it could not error in because it could not find the function ggplot2 because ggplot2 is under ggplot is under ggplot2. So let me run this now. Okay, this should run. All right, so tell me please if you were able to generate this plot. Okay, waiting for your chat, please, if you were able to generate this plot. Okay, so let's briefly analyze this. You have your actual, this is your observed point, this is observed education and hourly wage. All of the points here, class, pertain to the 526 observations. You have the pair education on the x-axis and hourly wage on the y-axis. So every point here is an actual data point. Now this one is our regression line. This is your hourly wage is equal to negative 0.9 plus 0.5, I think 505 times your education. And then we told R to create a geom segment. So this is the segment where you're getting, okay, here it's the, if I go back here, take note of the, okay, where's my R? Right here, geom segment. X end is equal to education, Y end is equal to fitted. So what does that tell us? What does that tell us? It tells us that the last point here on the x-axis should be the maximum, the last point of your education. What's the highest education value? And then here on the y-axis is your fitted value. Okay, so this is your fitted class. Okay, so it now creates this segment where you drop a line from the actual data point to your fitted value there. So you can see here the segment. So those actually are your residuals. Okay, so you have residuals that are quite high here. You can see that's the, I think the highest here. This can be the highest or this one. So it plots the segment of your y, okay, y value and your fitted value, which is your residual. Okay, so that's the difference between your actual observed value and your, this is your fitted value class, the blue line here. All right, so I hope that's clear, class. Any questions about that? So you don't have to learn the syntax now of ggplot2. Okay, just recognize, class, that there's this, the geo point will give us the points there, those black points. That's your geo point, and you're plotting your education and your hourly wage. The stat smooth is your linear regression line. Okay, that's your LM. And the geom segment are your vertical lines. Okay, vertical lines running from the value of your education up to the fitted value here. Okay, so those segments are, okay, it's a plot of your y, fitted value, and your education. All right, so you can see here the plot of the residuals. Okay, any questions, class? Any questions about that? Okay, so no questions. All right. Now, what we're going to do now, class, is to, I'm having problem with my, that's what happens when I shift the color. Okay. All right, so let's take a look at the outputs. Let me share this, LaTeX with you. Okay, so what's the formula, class, for the beta null and B1 for a simple linear regression? I hope this runs. Uh-oh. It's not running. I can't see the... Okay, let me just... Let me put it in another... Okay. All right, there. Okay, so this, class, is the formula for your beta 1. Okay, so let's just quickly understand what this is. Okay, so this is your beta 1 class, right? Hat, so this is your intercept. And what's the formula for your intercept? It's the summation of the, this is your X, this is your education, X minus X bar, so this is education, and then Y minus Y bar, this is your hourly wage. And the summation of that. Now this forms part of your what class? This is quite similar to what? This is similar to Actually, class, if I just complete this, so x sub I minus x bar times y sub I minus y bar, okay? And then divided by n minus 1. What is this actually, class? What is this? This one. If I divide this first by n minus 1, what is this expression? The cross product of the differences of your data points with respect to the average. So ano to, class? Do you recall from your stat what is this expression? Hello, class? What's that? That's your standard deviation. Okay, closer. Hindi siya standard deviation kasi, class, ang standard deviation, you're just taking a look at, ang standard deviation, class, is, first class ang standard deviation, may square root, di ba? And it's x minus x bar, x of I minus x bar, sorry. And then squared, di ba? Over n minus 1. Okay? Pag may square root siya, standard deviation yon. Without the square root, this is your, what's this, class? Yes, thank you, Abigail. Yeah, Friedrich, thank you. That's your variance, class, no? Variance. If you're getting the variance, if you're getting the of a particular variable, of one variable. But what about this, class? What's this? So it's not x with x, it's x with y. So this is your, you call this, class, your, this is your variance, di ba? This is your sigma squared. How about this, class? This is your covariance, and it's written sigma x comma y. Take note, no squared here. No? You have your two variables here. Or this one, class, can be written as sigma x comma x, x with x. So this is your variance. This is also your variance. Okay, you can just put one x here, not two x's. Okay, sigma xx means two variables, means covariance. Variance to. Ito naman, covariance, class, sigma x and y. You're getting the how x varies with y. So this is your covariance. Okay. How about this, class? So let's also put summation of x minus x bar squared over n minus 1. Okay. So the complete formula is actually this one. What's this one, class? What's this one? We already answered this, class. What's this one? This is your class. Ito, class, ito. What's this? X minus x bar times x minus x bar. What's that? This is your class. Hello? Error? No, not the error. Class, this is the variance. Diba? Ang formula ng variance, x or y minus the average, diba? Squared over n minus 1. Summation nun. That's your variance. This is the variance of x. This is the covariance of x and y. Notice pareho yung formula nila. The only difference is that here, you're letting x covary with y. Kaya covariance yan. No? Ito, variance of x or covariance of x with x. And the complete formula has n minus 1 sa denominator. So, I hope, class, na, kasi basic stat to no? So, we delete this, class. We delete that. So, it reduces to this one. So, which means, class, that the beta 1 class, the slope is actually equal to the covariance of x and y divided by the variance of x with x. Or this can be written as the covariance of x comma y, covariance to class, hindi standard deviation, divided by the variance of x, sigma squared. And then I'll just put one x there. Hindi dalawang x, no? You can write it as double xx and then sigma lang. All right, this is sigma x comma x. So the slope can be solved as the covariance of x and y divided by the variance of x. All right, so let's take a look at that, class. Let's see if, let's validate that formula. Clear the drawings. Okay, so ito, class, may over n minus 1 talaga yan, no? Na-cancel lang sa pareho. All right. Okay, sige, gawin nga natin, class. Okay, so we can actually validate the formula, no? Tingnan nyo to, class, before I share this with you. And I'm not going to share it with you. You do it yourself, no? So what's this? The slope B1 is, okay, we have the sum. Let me put it back near the... So what are we doing now, class? We're actually validating the values of your slope first and then your intercept. So it's almost time. So here, class, I'm attaching wage so that I can just use the education and make sure, class, later on to detach, no? Wag natin kakalimutan, minsan mas maganda yung pagka-attach, i-detach yung kagad. As if you're going to use it again, attach naman. All right, I'm creating this object B1, okay? And ito muna, class. Ito muna. So it's sum of what? Education, which is x1, minus the mean of education, okay? And then times hourly wage minus the mean of hourly wage, right? And then make sure to put all the parentheses correctly. So minumultiply natin, di ba? X minus x bar, it's this one. Y minus y bar, it's this one. And then yung sum na to, isa-sum up natin. And then divided by, okay, ganun din, no? Sum ng, kopyahin nyo lang to, education, this one, minus mean of education. And then you have to square this. Caret squared, and then close. Okay, sige nga, class. We'll end in this. We expect to get what? We expect to get yung negative 5, di ba? Ano yung value nun? Let me get that, class. So, sorry, nawala yung function. Here. So that's mod 1 dollar coefficients. Okay. So that's 0.54, no? 0.541. We should be getting 0.541 here. And kindly chat, please, if you were able to get it. So pinakita ko lang dito, class, ano yung formula? Paano kinukuha yung formula to get the slope? So it's the covariance of x and y divided by the variance of x. Or the covariance of x with x. Covariance of x and x. Pareho lang yun, class. Sige nga, class. Kindly, please, if we get the same value. And then I'll just give this to you. Okay, did you get, class? Did you get negative 5.41, class? Waiting for your chat, please. Did you get 5.41? Okay, good. Good. I hope you got it, class, no? Kasi ito, as I said, we're just learning ano ba yung formula ng slope. Well, the slope, this is for a simple linear regression class. No? Iba yung formula kapag multiple linear regression. We're not going to get the formula and use it sa multiple linear, but at least a simple makita natin na for a simple linear regression, the slope is actually equal to the covariance of x and y divided by the variance of x, okay, which is just this formula. The complete formula is over n minus 1, no? Kasi ang variance may divided by n minus 1 yan, no? For a sample. No? And ito din, divide by n minus 1. So magka-cancel out lang yan. So if I run this class, okay, I'm getting 0.541, which is the same as yung value kanina, no? Yan, no? 0.5413. 3593, exacto. Okay? All right, and then I shared with you how about the formula for the slope, which is just the slope is equal to the average of y minus, you have to know this first, the intercept times the average of x. So I also gave you the formula, okay? The formula, and you should be able to get also negative 0.90. All right, with that, class, we end our discussion for today. Thank you so much for your patience. I hope you learned something. May natutunan ba ngayon? Mabilis ba yung discussion natin or tama lang? Class, feedback please. I'll stop recording.